Fleas, those minuscule bloodsuckers, have plagued humans and animals for centuries. Let's dive into their world and uncover lesser-known aspects that might surprise you. 1. The Black Death Connection. During the Middle Ages, the Black Death plague swept across Asia and Europe, causing massive fatalities. Fleas played a crucial role in transmitting the plague bacterium, Yersinia pestis, to humans. Today, antibiotics and sanitation practices keep plague deaths minimal, but fleas remain a vector. 4. Blood feeding and flea poop. Adult fleas feed exclusively on blood, taking up to 15 blood meals a day. After digestion, they excrete dried blood waste, flea feces, or flea dirt. Flea larvae feed on this dried blood residue, often found in pet bedding. 5. Slim and agile bodies. Fleas inhabit fur or feathers, and their thin, smooth bodies allow easy movement. Their straw-like proboscis remains tucked under their belly when not in use. Leg structure and muscle power. Fleas possess a leg structure that is nothing short of a marvel of nature. Their 6 legs are equipped with specialized adaptations, but the hind legs play a crucial role. These hind legs have a unique combination of joints and muscles, allowing fleas to generate incredible power. Fleas can catapult themselves up to 350 times their body length using these legs. Muscle power and acrobatics. Despite their tiny size, fleas rely on an intricate system of muscles to execute their gravity-defying leaps. The secret lies in their hind legs, where powerful muscles contract rapidly, generating an explosive force that propels them into the air. Picture this. In just 1/20th of a second, a flea can catapult itself distances of up to 350 times its body length. This dynamic jumping technique not only aids in their survival, but also showcases their strength-to-size ratio that puts many larger animals to shame. Mechanics of flea jumps. Fleas use an intricate 3-part lever system for their jumps. Their coiled tendons act like springs, storing and releasing energy rapidly. When preparing for liftoff, a flea's powerful hind legs generate a force equivalent to over 350 times its body weight. The impeccable coordination of their specialized leg structure allows them to achieve these astonishing jumps. Factors influencing jumping. Fleas' remarkable jumping abilities are influenced by various factors. Leg structure. Their powerful muscles enable rapid propulsion. Environmental conditions. Temperature and humidity impact their performance. Fleas are highly sensitive to environmental cues, and variations in these factors affect the distance and height of their jumps. Fleas, those seemingly insignificant insects, defy expectations with their incredible abilities. From their leg structure to their muscle power, they showcase nature's precision in crafting tiny but powerful creatures. If fleas were as big as human beings, their strength and abilities would be quite remarkable. Let's explore some fascinating facts about these tiny creatures. Jumping power. Fleas can jump around 30,000 times in a row. If they were human-sized, they would be able to jump over the Eiffel Tower with an acceleration force of 140 g. That's an acceleration rate 50 times greater than a rocket taking off into space. Rocket. Imagine a human jumping 300 feet in a single leap. That's the equivalent of a flea's incredible jumping ability. Lifting strength. Fleas can lift objects 150 times heavier than their own body weight. If they were human-sized, this would be like a person pulling 24 million pounds. That's 12,000 tons. Biomechanics of jumping. Fleas achieve their impressive jumps through a combination of specialized leg structures and rapid muscle contractions. Researchers have debated whether fleas push off using their tibia and tarsus, similar to our shin and foot, or their trochanter, equivalent to human knees. Both mechanisms contribute to their extraordinary jumping ability. For further exploration, you can refer to scientific studies on flea mechanics and jumping prowess. These tiny acrobats continue to amaze us with their agility and strength. Ancient beginnings. Genetic evidence suggests that fleas belong to a specialized lineage of parasitic scorpion flies, Mecoptera. The earliest known fleas lived during the Middle Jurassic period, which dates back approximately 200 million years. These ancient fleas likely originated on mammals and later expanded their reach to birds. Fossil evidence. Fossils of fleas have been discovered in various locations. Australia. A fossil flea found in Australia is claimed to be 200 million years old. Baltic amber, Oligocene. Other known fossil fleas closely resemble their modern counterparts. Adaptations and persistence. Fleas have survived and adapted over millions of years. Their specialized leg structure, powerful muscles, and unique jumping abilities have allowed them to thrive. Despite their tiny size, fleas continue to be significant carriers of diseases and pests. Fleas have been around for an astonishingly long time, evolving and persisting through various geological eras. Their ability to adapt and their role in history make them both fascinating and formidable creatures. The world's largest flea, Hystercopsylla schefferi, resides inconspicuously in the Pacific Northwest. Let's uncover its colossal features. Size and appearance. The Hystercopsylla schefferi can reach nearly half an inch in length. Its head alone is comparable in size to a cat flea or dog flea. Until recently, no confirmed photograph of a live specimen existed. Elusive discovery. Despite ubiquitous digital cameras, capturing this giant flea remained a challenge. The flea lives on the mountain beaver, Aplodontia rufa, a common forest and garden pest. The elusive mountain beaver, secretive and mostly nocturnal, made the search difficult. The flea hunt. Biologist Merrill Peterson embarked on a mission to photograph the world's largest flea. He found drawings and dead specimens but lacked live photographs. Luck came through a biologist friend, Peter Wimberger, who knew of mountain beaver habitats. Photographic triumph. Merrill and Peter enlisted undergraduates to dig out mountain beaver tunnels. The flea, which spends time off its host, was sometimes found in nest material. Scores of photographs now exist, and the world's largest flea will be preserved in the insect collection at Western Washington University. So, amidst Bigfoot legends and oversized lattes, the Pacific Northwest harbors a colossal flea that defied documentation until recently. Fleas, despite their pesky reputation, do have natural predators in the wild. Let's explore some of these fascinating flea foes. Spiders, those eight-legged architects of silk, also contribute to flea control. While not exclusively focused on fleas, they do catch and consume them. Spiders play a vital role in maintaining insect populations in various ecosystems. Ladybugs, lacewings, and syrphid flies. These insects feed on adult fleas and their larvae. While they prefer other insects over fleas, they still contribute to flea population control. Ladybugs, in particular, are known for their appetite for aphids and other small insects. Remember, these natural predators help maintain ecological balance by keeping flea populations in check. So, the next time you encounter a frog or spot a spider, appreciate their role in flea management. Behavior and life cycle. Fleas prefer warm temperatures and moderate humidity. Their life cycle includes egg, larva, pupa, and adult stages. Eggs hatch into larvae, which feed on flea dirt, dried blood waste. Pupae spin cocoons and emerge as adults when they sense a host nearby. Eradication strategies. Nematodes. These microscopic, multicellular worms play a crucial role in controlling fleas. Two species are particularly effective. Steinernema carpocapsae, SC targets highly mobile surface-adapted fleas and their larvae. Steinernema felshii, SF resides in the soil and preys on soil-based fleas. Nematodes parasitize fleas by entering their system through pores and body openings, releasing bacteria that kill the pests. Remarkably, nematodes hardly harm other soil-dwelling organisms. Frogs and toads. These amphibians are voracious eaters, with a diet that includes insects like fleas. Frogs and toads, especially the larger species, consume fleas as part of their regular meals. However, their population tends to be low in dry land environments where fleas predominantly reside. On a side note, some fleas in a flea circus were glued to the base of a circus enclosure. Miniature musical instruments were then glued to the flea performers, and the enclosure was heated. The fleas fought to escape, giving the impression of fleas playing instruments. Flea circuses still exist, using live fleas still exist. Operators choose fleas that show a predisposition to jump or walk, then harness them around their necks using thin gold wire and attach them to props which the fleas then move. Fleas are usually harnessed for the whole of their short lives. Soviet flea pioneers. In 1959, the Soviet Union launched a series of biological experiments aboard the Sputnik 3 satellite. Among the passengers were fruit flies, bacteria, and, you guessed it, fleas. These tiny astronauts experienced weightlessness and cosmic radiation. Flea adaptations. Fleas' remarkable jumping abilities and resilience allowed them to survive the rigors of space travel. Their exoskeletons shielded them from radiation, and their small size minimized the impact of microgravity. The Japanese military used plague-infected fleas and flies, covered in cholera, to infect the population of China. They were spread using low-flying planes and with bombs containing mixtures of insects and disease. 440,000 people died as a result. Natural solutions. Diatomaceous earth, DE safe for pets. DE damages fleas' exoskeletons. Beneficial nematodes. These microscopic worms attack flea larvae. Dish soap solution. Mix dish soap with water and spray infested areas. Lawn care and planting. Regular lawn maintenance helps reduce flea habitats. Plant flea repellent herbs like mint, lavender, and rosemary. Professional pest control. Seek expert assistance if infestations persist. They can provide targeted treatments without harming pets. In conclusion, fleas are some of the most disgusting and interesting insects on our planet.